Hello everyone, thank you for joining us today for our webinar, Elimination of Hydrogen Sulfide Odors with CAIROX CR Potassium Permanganate Tablets. I am Liz Mueller for Carus Corporation. Today we have our speaker, Mr. John Bohl. A few housekeeping items before we get started today. Our webinar is being recorded and it will be available on demand after the live session today. All attendees will receive a follow-up email after the webinar that has the link to access the presentation. We encourage you to share this within your organization and network. If you're interested in receiving a PDF of today's presentation, please contact me directly and I will see that you get that. To ensure the best audio quality, we have everyone in listen-only mode. If you have any questions, we encourage you to submit those throughout the presentation as you think of them using the questions pane and the GoToWebinar panel. We will be taking questions at the end as time permits. If there is a question that we're not able to get to, we are able to receive your contact information when you ask a question and we will follow up with you directly. Here is a look of webinars that we've hosted so far this year. These are available as recordings for viewing on our website. You'll see here the link to access those webinars. You'll find them on the right-hand side of the page when you get there. We have one additional upcoming webinar on May 18th with Dr. Judy Westrick from Wayne State University presenting a multi-barrier approach, the removal of microcystine by conventional treatment. If you're interested in registering for that webinar, it is available on our website, and again, the link is here. We'll also be announcing our second half of the year webinar series that we will most likely start in August or September of this year. That will be on our website, our various social media platforms, and we will also send out email blasts. If you are not currently receiving our email blast or following us on our social media platforms, please let us know and we can add you to those email blast list. Here's a few ways to find us. Visit us at our website, which is cairoscorporation.com, where we have product and technical information, webinar links, webinar schedules, and more. We also have listed here our general sales and marketing email address as well as mine. And then we have at the bottom here, you can follow us on various social media platforms such as LinkedIn, YouTube, Google+, Facebook, or Twitter. On these locations, we frequently will post technical articles, upcoming events that we're attending, webinar schedules, as well as recordings to webinars that we've previously hosted, and much more. At this time, I would like to take this opportunity to introduce our speaker, Mr. John Bohl. John is our Global Technical Program Manager at Carus Corporation. John has been with Carus for over 40 years, serving in a variety of sales and marketing positions. The Technical Service Department provides customer support, including on-site lab testing, plant-scale startup, and troubleshooting services. John earned his bachelor's in engineering from Purdue University, West Lafayette, Indiana. He's a member of the Water Environment Federation, WEF, and the American Water Works Association, AWWA, where he has served as the AWWA Illinois Section Chair from 1992 to 1993. We welcome Mr. John Bohl.
All right, thanks Liz for getting us started this morning. I think I'll start by just saying that today I'm filling in for Dr. Pamela Dugan, who prepared much of today's content, and at the end of the presentation we'll list her contact information as well, and she's really a great resource if you have any questions in the future. Today we have, I think, a great story for you because it features our flagship product, CAIROX Potassium Permanganate, and it introduces it in a new form. The new product is called CAIROX CR Potassium Permanganate Tablets, and I'll probably often refer to it just simply as CR, which stands for Controlled Release. Our opening slide shows you the highlights of the presentation and a photo of the tablets. You'll note that we're focusing on permanganate's elimination of hydrogen sulfide as it relates to wastewater treatment and collection. I'll include data on some actual installations, and at the end I'll summarize what was presented. And we should have time at the end to answer questions that you may have. For those of you who are unfamiliar with Carus, I'll start with just a little bit of background information. Carus Corporation has been a leader in permanganate products and applications research for over 100 years. In fact, in 2015, we celebrated our 100th anniversary. Our manufacturing plant and our main headquarter offices are located in northern Illinois, and we sell permanganate products globally. So we also have offices in Europe. The Carus plant is the largest permanganate production facility, and we are the only manufacturer in the Western Hemisphere. Our chemistry expertise really lies in permanganate, manganese chemistry, and also oxidation chemistry. And with these chemistries, our marketing focus is in the areas of drinking water treatment, manganese removal, wastewater contaminant control, industrial oxidation processes, and environmental pollutant remediation. For most of its history, permanganate has been manufactured as a convenient and stable crystalline powder. To use it, this dry material is dissolved in water, and a solution is made that can be applied directly into the treatment process. Since the late 1990s, we have also offered permanganate as a concentrated pre-mixed liquid, and in this form, permanganate chemistry is available for immediate use in an easy-to-use format. Now, due to its unique chemistry, permanganate is recognized as an effective treatment for odor control. A compound's characteristic odor is often related to its structure and to different functional groups that are part of that structure. Permanganate oxidizes these functional groups, producing an odor-free product. This includes those odors that are generated during wastewater collection and treatment. About 30 years ago, the wastewater industry investigated and discovered that by applying permanganate directly into collected wastewater or into wastewater biosolids, odors could be quickly eliminated. And although there are many unpleasant odorous compounds that are generated and released from wastewater, by far the most problematic is hydrogen sulfide. Sulfide is undesirable for three primary reasons. It's toxic, and therefore it is a health and safety risk. It is odorous at very low levels, creating nuisance, fugitive odors and worker and neighbor complaints. And it reacts to produce corrosive sulfuric acid that degrades infrastructure. So what are the physical chemical characteristics of hydrogen sulfide? Well, first of all, it's a colorless gas, so you can't see it, but it is detectable by nose at very, very low concentrations, typically as a rotten egg smell. It's caused by septic conditions during wastewater collection and treatment. It's produced by the biological reduction of sulfates that are in the water and the decomposition of organic material. And it can form virtually at any point within the wastewater treatment system. Now, although sulfide is generated at many locations, as it relates to CR tablets, let's focus just on collection systems today. All three of the adverse sulfide impacts that I just listed are present in collection systems. And wastewater collection is really, arguably, one of the more critical elements in today's urban environment. It protects public health by removing sanitary waste. It enables productive economic activity, and it contributes to a high standard of living. But because these systems are large, there can be certain problems. One is slow wastewater flows and long retention times contribute to anaerobic conditions, and these are the precursors to microbial-induced corrosion in sewer and wastewater treatment structures, and the precursor to odors. Now, on the upper walls of a sewer system, microbes can take up H2S and oxidize it with air to form sulfuric acid. This is an extremely powerful and it can corrode concrete and metals, which are the most common materials used in large sewer pipes. Of course, of greatest concern are the safety hazards associated with hydrogen sulfide gas, which is acutely toxic and flammable. The bar graph on the right is one that many of you will be familiar with. It's from the US EPA manuals, and it shows that at very low parts per million concentrations, less than 1 ppm, the odor is easily detectable. And it doesn't take much increase in that concentration for sulfide to become a very serious risk. And I can tell you from different systems that we treat and visit, it is very simple for us to find, and often we find H2S levels as high as 100 parts per million in a lot of buildings and rooms where we are visiting. Workers who are exposed to these conditions for 8 hours a day can suffer adverse health effects. At low concentrations, exposure to H2S has been linked to fatigue and headaches and eye irritation, sore throats, and other health problems. Here are some examples of the corrosion to collection system that many of you may be familiar with. On the left, we have a transmission line which has become so thin that in the course of excavation, the worker's shovel went right through this particular piece of pipe. And on the right, a typical situation that you see with concrete corrosion in a manhole, and it renders those ladder rungs virtually unusable at this point. Now we know that odors are released at many points in the system, and it's usually at points of turbulence. And by injecting permanganate into wastewater upstream of those odor points, the problem can be eliminated. Importantly, with permanganate, you do not need much reaction time. Permanganate destroys hydrogen sulfide in a matter of seconds. So how do you dose permanganate into collected wastewater? For potassium permanganate crystalline material, you use dry chemical feeders and drum handling equipment. In larger systems, you may use a recyclable bin, feeder, and dissolver system. And at some sites, potassium permanganate is mixed in a predetermined amount of water, and it is used to prepare a stock solution. This solution is then dosed into the water using metering pumps. You can see that these feed systems can be large, taking up a large footprint, and in fact, they should be housed in a building protected from the weather. If you're using concentrated CAIROX liquid permanganate, the feed system may be smaller and easier to use, many cases just requiring a metering pump. But again, preferably, it should be housed in some type of shelter. At a master pump station, such as the one shown here, a building is often available. In this case, a chemical feed room and a buried chemical feed line were already designed into the system at the start. So it was easy to install a CAIROX liquid permanganate feed system. But what do you do if you have a situation like this? A remote location with often no electrical power, no water supply for chemical mixing or dilution, no shelter, and no security. Or in this type of situation where you have a large lagoon or evaporation pond or catch basin, and in this case access to all of the water in the large body of water is difficult. Well, we've worked to come up with a practical solution for these particular problems, and the solution is are CAIROX CR potassium permanganate tablets. The CR, which is controlled release technology, is fast to react with hydrogen sulfide and other organic producing compounds. It makes an excellent choice when retention times are short. These tablets are a passive system, safe and easy to use, and the treatment is deployed typically in a polyester mesh bag for rapid oxidation of hydrogen sulfide in wastewater lift stations or gravity interceptors. The tablets are designed to be easy to use, and they can provide sulfide control for many days before new tablets are needed. The tablets contain about 80% permanganate that is combined with non-hazardous binders that facilitate sustained and controlled release. The release, as I mentioned, can be over several days and in some cases over several weeks. The tablets that are shown on the right are 2 inches in diameter and 3/4 of an inch thick. They weigh approximately 80 grams each. This CR tablet controlled release formulation dispenses permanganate slowly into flowing water, and the permanganate, once released from the tablet, reacts very, very quickly with H2S and other organic compounds that produce odors. It makes an excellent choice when immediate results are needed near the point of odor release. Now, during the early development of the tablet technology, we looked at a number of different configurations in terms of the geometry of the tablet, as well as the mass loading of permanganate in each tablet, which ranged between 70% to 90%. This graph illustrates the different release profiles that were measured in a jar test in the laboratory as a function of time. For these tests, the tablets were placed into the reactor and the mixer was turned on, and it was a paddle mixer in this case. So we had some low flow, some low turbulence in the system. The permanganate concentrations in solution were measured each day to understand how much was being released. And for each case, the test conditions were kept as identical. We found that by increasing the permanganate mass loading in the tablet, the percentage of permanganate that was released increased as expected. I think you can also see from this graph that the release is slightly faster in the initial days and then slows to a more consistent release as time passes. That previous slide showed the percent that was dissolved into the liquid. This shows that same data in terms of pounds of permanganate released per pound of tablet. And you can see that it follows the same general characteristic as the previous slide. As we increased the mass of permanganate in the tablet, we did release more permanganate into the system. Now here's some data that I just received recently from an actual field trial in New England. The system was a leachate flow coming from a landfill site, and there were a significant amount of sulfides present in this leachate, running somewhere between 2 and 3 milligrams per liter as dissolved sulfide. The flow was relatively consistent at 250,000 gallons a day, although it was variable at times between a low of 140,000 to a high of 340,000 gallons per day. Now, at one site and one bag, it was not a significant enough permanganate to get good control. So in this particular case, 2 bags were used at 2 different sites one downstream of the other. In Site 1, there were 20 pounds of tablets that were placed in the bag, and in Site 2, approximately 15 pounds were placed in the bag. Now you can see that the release rates are slightly different, but there is an explanation for that, and that is in Site 2, a metal perforated canister was used to hold the tablets, where the polyester mesh bag was used at Site 1. So we did see a slightly faster release, although relatively consistent, at Site 1 when compared to Site 2. The test ran for over 20 days, and at the end of the test time, approximately 17 pounds of permanganate had been released into the system, and during that time 5 million gallons of leachate flow had passed through the system as well. And this calculates out to be about 0.4 to 0.5 milligram per liter dosage over those 20 days. Now the next few slides are focused on several tablet trials that were run in late 2015 as well as through 2016. They were conducted at a Midwestern collection system, and the typical daily flows at this system were 3 million gallons per day. Now they were receiving neighborhood complaints about strong H2S odors coming from gravity interceptors. In order to collect the data, we suspended an otologger H2S analyzer in the gravity interceptor manhole located upstream of where we were going to deploy the tablets. We used that otologger to collect baseline data before treatment. And that's illustrated in the photograph in the upper right-hand corner. "10 pounds of CAIROX CR tablets were placed in the mesh bag and lowered approximately 6 inches below the water level in the interceptor. Several times a week the bag was weighed and then replenished with new tablets if needed. In addition, we continuously collected H2S data and the amount of rain that fell during the test period." Now this is a busy graph, but it's typical of what you might see if you were collecting atmospheric sulfide data in a collection system. The chart shows both untreated and treated H2S atmospheric concentrations that were measured during the trial. The blue lines designate baseline H2S data prior to the CAIROX CR tablet usage. The orange lines are measured H2S concentrations during the trial. The highest recorded atmospheric peak was 5 ppm during the 5-day trial. And because H2S has a very low odor threshold, its odor can be detected below 1 ppm. The average treated atmospheric H2S concentration was 0.2 ppm throughout the monitoring period, with a major odor release occurring between 2 p.m. in the afternoon and 9 p.m. at night. In addition to H2S concentrations decreasing, resulting in rapid odor elimination, visual inspection showed that an oil and scum layer that typically floated on top of the water, which indicated evidence of fats, oils, and greases, was also being attacked by the permanganate treatment. Now, if you already have a thick buildup of fats, oils, and greases in the system, it's best to break it up initially, either with a vac truck or with a high-pressure hose, and clean the system before you actually deploy the tablets. This speeds up the whole process. And the H2S removal showed H2S removal at lift stations and also slow removal of any accumulation of fats, oils, and greases. This next graph is a summary of CAIROX CR tablet field trial that ran for several months over the summer and fall of 2016. We were fortunate to have easy access to the site, which allowed us to collect a lot of data so we could understand the tablets, how they performed in real field situations. On the primary y-axis, we have measured hydrogen sulfide concentrations and/or tablet weight provided as a function of time. The hydrogen sulfide concentrations are illustrated by the orange line and the tablet weight with the blue line. On the secondary y-axis is the daily rainfall, which is provided by the green line. We ran this trial for a little over 2.5 months. We initially put 10 pounds of tablets in the mesh bag and placed them down in the manhole and continuously collected hydrogen sulfide data up gradient with the odor logger. Each week we retrieved the bag and weighed it so that we could record the tablet mass loss over time. And we also reloaded the bag with new tablets, generally 10 or 12 pounds each time. For this trial, the average lifespan of the tablets was between 7 to 8 days. And it's important to point out that each site will be different, and the longevity of the tablets depends on flow and the amount of precipitation that occurs. The nice thing about the tablets is that if there's no flow occurring in the system, the tablets will not release permanganate. Now, during the duration of this test, the highest recorded level of hydrogen sulfide was 34 parts per million, and the average H2S concentration was approximately 1.2 ppm. The tablets were very effective for passively treating the H2S. And although we were at the site several times a week, we did this to collect data. Once the tablets are deployed and the flow is moving through the system, checking on the tablets once a week is really probably not going to be necessary. This slide provides an overview of our second CR case study results. The graph laid out in the same way that we did in the previous slide, with hydrogen sulfide in parts per million and tablet weight in pounds over time. We also show the daily rainfall on the secondary y-axis on the right. This trial was conducted at the same town as the previous test. However, the trial ran over 4 months during the summer and fall of 2016. The maximum H2S concentration was 24 parts per million in this case, and an average of 0.74 ppm was measured with the odor logger. For this trial, the lifespan of the tablets was between 7 and 14 days, but again, it will always depend on the rainfall and the flow through the system. So a typical question that we will be asked is, how often do I have to replace the tablets? This table provides a brief summary of the starting and ending weights of the tablets at 4 different lift stations in Iowa. As you can see, the amount of time the tablets will last will vary at each site, and if there's a lot of rainfall, the tablets will be consumed much faster. However, as I mentioned earlier, if there's no flow or rain, the tablets will not be releasing permanganate, which is especially helpful at remote locations where access is restricted. So let me summarize what we covered in the presentation here today. First, the CR tablets provide effective odor control in remote locations where electricity and water supplies may not be available. By eliminating sulfide, you can prevent corrosion in the system. It's a passive treatment, and it's simple to feed. It's long-lasting, so it requires less manpower. and by eliminating hydrogen sulfide, we can eliminate health risks and improve the health and safety profile of the system. I'm going to turn it back to Liz, and she'll finish up with the webinar.
Great, thanks, John. Here is a quick look at our North American Regional Sales Manager broken down by territories. So you'll see here by the territory the sales manager name and their phone number. So if you do have any questions about the tablets or would like additional information or would like to look at possibly using these at one of your facilities or sites, feel free to get into contact with one of your regional sales managers. Also, here is our Carus Europe sales management team. And finally, here is the contact information for Dr. Pamela Dugan, who is our Business Development Program Manager, as John mentioned, who has done extensive work on these CR tablets, as well as Kelly Frasco, which is our Global Product Manager, and John Bull, who presented on behalf of Pamela today, our Technical Service Manager. And again, if you do have any questions, please go ahead and type those into the questions pane and go to webinar. If you think of anything after the fact, feel free to get into contact with any of us and we can get those answers for you as well. And it looks like a couple questions are coming in. So one question is, are the mesh bags available through Carus that were discussed during the presentation using to deploy?
The answer to that question is yes, and I believe that one bag is provided for an initial purchase of CR tablets, but additional bags can be purchased after that point from our customer service department. So there's a second question that came in, and that is, could or should a tablet erosion feeder be used for more control? There are situations where a tablet feed system can be used, and it does provide more control because you can control the amount of flow going through the erosion type feeder. Those are convenient as well if you have access to some type of system where you can pipe the flow to the feed system, and it works very, very nicely.
Okay, great. Another question is, there was the slide that talked about estimating the length of the tablets, and how do you exactly know when it is time to replace those tablets? Is that based on weighing the tablets before and then frequently weighing them and color?
Yeah, typically I think what you're going to find in any particular system is that you will establish a routine of when you know the weight of the material is getting down very, very low. You probably do not typically go until the mesh bag is totally empty. And I would match it probably to a routine that the collection system crew uses to go and check on locations throughout the system. We tried to design the tablets so that you would not have to go out and visit the sites more often than once a week. And if you can get more longevity out of the tablets and have to visit the system less often, that's even more advantageous. But weight is probably the best way to do that at this point.
Okay, great. Right now it looks like that's all the questions that we have. Again, if you think of any questions after the webinar concludes today, please get into contact with us. As I had mentioned, we will send out an email to all attendees that has the recording link to this. Please feel free to share it with people within your network. If you would like a PDF copy of today's presentation, please get in contact with me and I will be sure to see that you get a copy of that. Again, we thank John for presenting and we thank everyone for attending our webinars, and we should be announcing our second half of the year webinar series in the next month or so, so be on the lookout for that. Thanks, everybody.